Lesson 3, Equivalent Circuit. Section 3.2. Carriers and Current Gain. This is an NPN transistor. The semiconductor regions are called, from left to right, emitter region, base region, and collector region. The major carrier of electric charge in an N-type semiconductor is the electron, while in a P-type semiconductor, it is the hole. An electron carries a negative charge, and a hole carries a positive charge. If a DC voltage source VBB is connected between the base and emitter, and VBB is positive, then the PN junction between the emitter region and base region is forward biased. Another DC voltage VCC is applied across the collector and emitter, and VCC is set higher than VBB. Then the PN junction between the collector and base is reverse biased. Electrons in the emitter region drift through the forward biased junction. The holes in the base region drift to the opposite direction. The electrons in the collector region move away from the reverse biased junction. The density of carriers in the emitter region is made high, and that in the base region low. So the majority carrier of charge through the forward biased junction is electron. Most of the electrons, which flow into the base region, diffuse through the base region, and reach the collector region. A small portion of the electrons recombine with holes in the base region. The density of holes in the base region is made low, and also the width W is fabricated short, to make the probability of recombination in the base region very small. All of the holes, which flow into the emitter region, recombine with electrons in the emitter region. The same number of electrons, lost due to the drifts and the recombinations in the emitter region, is supplied through the emitter electrode. This flow of electrons is the current IE. The same number of electrons, increased by the diffusion into the collector region, exits through the collector electrode. This flow of electrons constitutes the current IC. The same number of holes, lost by the drifts and the recombination in the base region, is provided through the base electrode. This flow of holes forms the current IB. A note should be made that there is a very small amount of holes in the collector region as a minor carrier, and it drifts to the base region. This is a leakage current from the collector to the base denoted by ICBO, similar to the reverse current IR of the diode. According to the data sheet of 2N3904, the typical value of ICBO is approximately equal to 0.3 nanoamps. It is very small, so we neglect this current. The currents have this relationship, IE equal IC plus IB. Alpha denotes the current ratio IC over IE, and HFE denotes IC over IB. HFE is expressed with this equation. HFE is called DC current gain. Exercise 3.2. This is your homework. Pause the video, and answer the problem. The author of this material is Takeshi Furuhashi, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.